Welcome, and thank you for joining today's webinar. My name is Vanessa, and I will be your WebEx technical support host. Before we dive into today's meeting, I wanted to provide a quick information on the webinar platform. All lines have been muted on entry and will remain muted for the duration of the webinar. Please submit questions throughout the presentation using the chat and select all panelists. A moderator will ask the comments and/or questions on your behalf at the end of the presentation. If you require technical assistance, please feel free to contact me, the host, via the chat panel, and I'll be happy to assist you. If you need closed captioning, please refer to the link in the chat panel. We also wanted to make you aware that today's webinar is being recorded. And now I'll turn it over to Lynn Wilkins to begin today's webinar.
Hi, I'm Lynn Wilkins, and I'm representing the Cohort Consortium webinar subcommittee. I'm very pleased to be kicking off the webinar series from 2021. Up front, we have our first webinar is the push button data sharing. It's a follow-up to a presentation that was at our virtual annual meeting in November, and for which there was a lot of enthusiasm and a lot of questions. So I'm very pleased that we're having this follow-up webinar. I would ask that you follow what webinars are coming. We have one on, the next one will be on cancer subtypes. And then we have one on aging, aging variables that are useful in cancer research, and one on early onset cancer. So if you follow along with the Cohort Consortium website, you'll see which webinars are coming up. I'd like now to turn it over to our two moderators for this webinar. We have Michael Jones from the Generation Study in the UK and Sam Antwi from Mayo Clinic. Thank you so much for joining.
Thank you. This is Sam Antwi, and today I have the privilege of introducing Dr. James Lacey and Emma Spielvogel. Dr. Lacey is professor and director of the Division of Health Analytics in the Department of Computational and Quantitative Medicine at City of Hope. He and Dr. Elena Martinez are the multiple principal investigators of the California Teachers Cohort Study. Dr. Lacey's work involves improving cohort infrastructure through epidemiology-driven use of informatics, data science, and data analytics. Before joining City of Hope and the California Teachers Study in 2009, Dr. Lacey spent 11 years with the NCI Division of Cancer Epidemiology and Genetics. His research there helped understand the natural history of uterine cancer and to uncover the links between menopausal hormone therapy and risk of uterine and ovarian cancers. Dr. Lacey received his PhD and MPH from the University of Michigan School of Public Health. Since 2015, Dr. Lacey has served as a member of the NCI's Board of Scientific Advisors. Now to Emma Spielvogel. Emma is a data analyst for the California Teachers Study. She first became involved in the California Teachers Study as an intern after completing a Bachelor of Arts degree with double major in biology and French studies from the Occidental College in California. She spent a year teaching English in a high school in France, and then joined the California Teachers Study full-time in October 2018. Emma provides technical and analytic support to everyone who conducts research with data from the California Teachers Study. Emma leads the California Teachers Study data visualization work, both for individual projects and interactive features on their website. Emma's work focuses on process improvement and the development of innovative materials that enables user-friendly navigation of the California Teachers Study cohort data. I will now hand over to Dr. Lacey for his presentation, followed by a presentation by Emma. Thank you. Dr. Lacey.
Thank you, Sam. Hello, everyone. It's great to be with you today. I'm very excited to be presenting with Emma, and very eager to hear what you think about what we've done to try to improve data sharing in the teachers cohort. Next slide, please, Vanessa. So who's excited about data sharing? Next slide, please. Joking aside, data sharing means a lot of things to us in the cancer epidemiology community, and it means different things for different stakeholders. And what I want to do today is sort of give you an outline of how we're going to approach this. From a presentation standpoint, I'll start and provide some of the background and sort of our rationale, and then hand it over to Emma for a demonstration of our new data sharing application. What I'd really like to do is, again, articulate our rationale in the teacher study cohort for why we wanted to change our data sharing strategy. Describe that approach and why we replace it with something new. Demonstrate that new solution, as I mentioned. Emma will do that. And then, as I said, it would be great to get your feedback on what we've done and see if this can help advance data sharing overall. Next slide, please. Of course, this is all happening as the NIH has finalized its data sharing policy, and this was made public last October, becomes effective about 2 years from now. The goals as articulated in the policy and as mentioned by Director Collins are ones that we can all agree with. We're all on board with data sharing as a key way to increase the quality and the openness and the access of research, particularly research funded by the NIH. Next slide, please. Oh, if we could go back one. That said, as that policy was put in place last fall, and with a 2-year window before it becomes official, there were a number of specific concerns about how this is going to be implemented. And I think those of us in cancer epidemiology know these quite well. There were some questions about what precisely is required, how we're going to define scientific data, when and who reviews the data sharing plans as part of grant applications, what particular accommodation is being made for data from human participants, when and for how long do we expect it to share, and that the policy specifically said that there would be a period of learning and an evolution of implementation practices. I think that's where we are right now, and we'd like to contribute to that as much as we can. Next slide, please. Of course, within cancer epidemiology, these aren't new issues to us. And as a community, we've been thinking about these for a long time. TCCPS hosted a workshop 6 years ago, back in October 2014. It was really driven by the advances up to that point in sharing genomic data, create an opportunity for additional new approaches to put in place the same advances for other individual level epidemiologic data. So that workshop back in October, many of you probably attended it, designed to identify challenges and solutions, figure out what are the key elements for epidemiologic data sharing, and identify what resources would be needed to advance data sharing. I do want to mention that at the same time, 2 days before that, there was a concurrent workshop on harmonization. And you know that harmonization and sharing often go hand in hand. Sharing often precedes harmonization, which then occurs when multiple studies share their data together. For purposes of today's talk, what we're really talking about is sharing, but of course, a lot of the issues come in with harmonization and the downstream use of shared data. Next slide, please. As part of that policy that NIH put out, there was a public comment period in the fall of 2018, and a number of cancer epidemiology stakeholders expressed specific concerns. And I do want to mention those here because, again, they helped us think about how we wanted to approach this for our cohort. Taking from the public comments that were posted in fall of 2018, a couple key points jumped out about epidemiologic data sharing. Our data are considered more complicated than genomics data. There's a lot of effort required to explain the design, study characteristics, particularly of long-term studies like our teacher study. General consensus that outside investigators can't just come in and start analyzing complicated study data. They need help to understand nuance. And really that's connected directly to the validity of the downstream result. How well someone can use those data depends on how well that person understands the source and the nuance of it. Data dictionaries alone are not sufficient for someone to understand the complex analytic data in cancer epidemiology. And one of the key value adds of a cohort study is its ability to change and evolve and improve over time. So that makes that question of static data versus ever evolving data particularly important for data sharing. And there are legitimate and real concerns, particularly for long-running studies, about whether the informed consent that participants gave is consistent with sharing in a quote-unquote open NIH database. Next slide, please. Those are things that we've been dealing with on our California teacher study. I think many of you are familiar with it. The website is there. Feel free to go ahead and take a look. The teacher study was one of the cohorts that NCI funded in the mid-1990s, launched in 1995-96. Includes about 133,000 women who've been followed continuously since. And there's been a team of multiple investigators at multiple sites in UC down there. Currently, it's being managed by a group of us from City Folk in UC San Diego and UC Irvine and UC San Francisco. Next slide. As a multi-site cohort from the beginning, we had been facing the data sharing challenges both internally on the CTS and externally. And by 2014, this is a schematic of how we had managed the CTS data. The different sites are represented by boxes. They're all in California. CPIC used to be in Fremont. The investigators have now moved to UCSF. But the approach from the beginning of the study through about 2014 was for each site to be responsible for a specific subset, specific domains of CTS data. That meant that our cohort's data were stored locally and combined manually, analyzed individually. So in essence, we were sharing every time we needed to do something as a study team. And that was increasingly unsustainable. Again, these aren't new or unique revelations on our end. Many of you have encountered the same things. These kind of data silos meant unequal access, efficient management, difficult to get visibility, and it really made it challenging to collaborate. And as we thought about it, as much as we use that term data sharing, if data sharing just means creating data sets and handing them off to an external user who then has that entirely in their environment, it's more like data giving. We moved away from data sharing. Data giving has a lot of problems. Next slide, please. A lot of you have heard, and we presented last fall as well, that since 2014, the CTS has been committed to taking a new approach based on a couple of core strategic data principles. Really, we wanted to go to a single environment to improve our analytic and data experience. We wanted one single set of data that everyone could use. We want one analytic environment where all analyses occur. We wanted one trusted version of tools and documentation, one uniform process for all users every time, and one shared workspace that would facilitate collaboration. And really what made this possible in the last 6 years that really wasn't an option when the cohort began back in the mid-90s is, of course, cloud computing. Next slide, please. At the core of that was a data warehouse built with the Sherlock Cloud team at the San Diego Supercomputer Center, which is part of UC San Diego. Warehouses have been around for a long time. They're designed to facilitate data analyses and drive insights. We took a lot of time-tested, proven techniques and configured the CTS data into a modern data warehouse. Combined them, normalized them, used some processes called ETL or extract, transform, and load, built that data warehouse, and then put on top of it with, again, the Sherlock Cloud partners, secure analytic environments where there are analysis tools and the ability to have that kind of collaborative analytic experience that we were hoping for. Next slide, please. But the infrastructure that the CTS has used in the last 6 years is more than just a data warehouse. And I do want to walk through a little bit of this before I hand it over to Emma, because it'll help to understand sort of where the additional need for data sharing tools came up on our end. Next slide, please. The public website, calteacherstudy.org, includes a lot of historical information. A lot of it is similar to what you all on your own cohorts have on your own websites. Metadata, aggregate results, copies of questionnaires, description of the study team, documentation, really a lot of public-facing information there. The controlled access environment includes that data warehouse I mentioned, and it's really where individual level analytic data and analysis tools exist within that secure remote desktop. Behind the scenes, we study management platform, which is a combination of Salesforce and then Smartsheet for project management. It's really used by our internal team, but as many of you know, tracking which data are being used and by whom, data sharing agreements, a lot of that stuff needs to take place in a study management platform, and that is integrated with our controlled access and public website environment. Next slide, please. So what a user wants to do really dictates where in this integrated ecosystem they start their journey with us. If someone wants to request access to CTS data, review study findings, look at surveys, explore aggregate data, some interactive visualizations, all on the website. You don't need to register. can go ahead and just start doing that right away. Next slide, please. If someone wants to get into an individual level analysis, request individual data, analyze individual data, do some deep exploration and some grant planning, or request a data export for a data sharing project, for example, a Cohort Consortium project. That all happens within the controlled access secure remote desktop environment. Relies on data from our data warehouse. So that's where we as a CTS team do all of our analysis, and that's where anyone who wants to analyze CTS data does as well. Next slide, please. Within the website, the For Researchers page describes a lot of these processes, and you can check it out there. There's a summary of data, there's a list of publications, and access to CTS data for. Next slide, please. Sorry. You can request access to CTS data or say that you're ready to submit a proposal. Excellent. So there at the bottom of that For Researchers page are the contact us form and the little window where you can propose an initial idea. I mentioned these because behind the scenes, those are part of our Salesforce environment. So those start a process then of creating those cases, and we automatically get notified of those, and that starts the collaborative process with you, our peer researchers. Next slide, please. Now, when that happens, the next step is for the CTS steering committee to review the proposal in detail. And the proposal form is something similar to probably what a lot of you have for your cohorts. It's similar to what the Cohort Consortium uses for its projects. At this point, we sort of revert back to that time-tested technique of email a Word document, have you fill it out, send it back to us. When we do that, then we can use some project management tools that help us keep track of that voting. But right now, that proposal form still exists in a good old Word document that gets sent around by email. Next slide, please. When it's approved, this starts a data sharing process that I imagine is pretty similar to what a lot of you are doing as well. Within the middle of the slide there, starting at the top, that green button, a researcher completes a data request form. And this is true for us internally on the CTS team and for anyone externally as well. We get that form, we review it. There is a specific data request form as well. I'll show you a screenshot of that in a moment. Once we get that specific data request form that says the details of the analysis, when does follow-up start, how do you want to define your case group, what kind of censoring criteria do you want? We take those, and this is where Emma comes in. We manually insert those choices into a couple of SQL templates. Those SQL templates extract data from our warehouse, and then we manually deposit those analytic files into that shared workspace. Researchers come in and use those data. We have that ability of, we know where the data comes from. It's all coming from our house. It's in that shared workspace. But next slide, please. What we found is this process of, sorry, if you could go back one more, please. Converting those choices, and here's an example from that sheet of if someone wants to specify what specific cancer outcomes their analysis is going to use. It's detailed, it's nuanced, it's into the weeds. Next slide, please. We take that information and insert it into those SQL templates. Those manual updates were a bottlenecking event. And even in the context of strong cloud computing resources, time-tested data warehouse techniques, we're running into this manual bottleneck. Next slide, please. And that's where we started thinking, what if instead we could give all users the ability to choose their own data via website? Get rid of that manual bottleneck and let all of you choose data on your own terms. And the idea that we kept coming back to is something that all of us have seen for a long time, SEER Explorer. Now we take for granted if we want access to SEER data, we go to that SEER Explorer tool, which is a website. It's secure. We can configure the custom SEER data we want and do everything we need with those SEER rates. Could we do something similar for the CTS? Next slide, please. Summer 2019, we started brainstorming this. In March 2020, right before we got sent home for the pandemic, we were down in San Diego and scoped out what a solution would look like. A couple of key things on this slide. We identified a couple of guiding principles. What was our overall vision going to be, and what were the user requirements going to be? So if we run through each of those, represented by a column here, the principles on the left, we wanted to be able to deliver truly customized data for every project. Anyone coming in and requesting data needed to be able to get custom data that they needed for their project. We wanted to automate as much as possible and leverage all of the technology and infrastructure that we built today. The overall vision would have the website integrate that proposal form with the data request form, make even more of that automated, get rid of manual processes across the board. And again, using that SEER Explorer example, could we replace those manual forms with some pick lists and menus and try to give all investigators a true self-service experience? A couple of user requirements. On the right-hand side, we needed to let users choose any combination of data they wanted. We know projects change, so the solution needed to be able to change and update over time. We wanted to create custom documentation to match every data set, and we wanted to have those data sets then deposited within that secure collaborative workspace to take advantage of the ability to collaborate. Next slide, please. And this got us thinking about the data sharing lifecycle. Again, this isn't specific to CTS, but if we start at the top, what does it take to share data in a cancer epidemiology setting? Those of us on the cohort side, we need to be able to disseminate knowledge about the data. Someone needs to identify what components of that data set are going to be shared. A data set needs to be created, data set needs to be delivered, and then that data needs to be harmonized to a target or analyzed by the end user. Next slide, please. So thinking about a solution here brought up a number of strategic decisions at each of those points. We again start at the top. Where is information going to be disseminated? What information? Who chooses what specific data are included in external data sharing request? Who creates the data set? How? Where is it delivered? And then who analyzes the data? If there needs to be harmonization, who does it? Where and when? Next slide, please. As we're thinking about creating an automated solution for this, it got us thinking about who does the actual work. And historically, there have been two approaches. One is for the provider to do the work of configuring that customized data set. The cohort does it. The other on the right-hand side is for a requester. Each of those has pros and cons, and it took two key tasks in the middle. So if we take the center, who chooses the specific data that a cohort gives to an external data requester? On the left-hand side, in the upper left, if the provider does it, if the cohort does it, some advantages. Cohort maintains control, helps ensure quality and consistency. On the negative side, it's a cost burden, it's unpredictable workload, and it's typically underfunded. If, on the other hand, a data requester chooses what specific data are in there, it increases the chance that the requester is going to feel like she got exactly what she needed. On the other side, there's a potential, going back to some of the broad concerns, that users don't have all the information they need to be optimally successful. We then move to the next step of sort of creating a specific data set. Again, if the provider does it, it doesn't require that provider to make all of their source data available to others. They sort of keep things in-house. On the other hand, it's inefficient, it's often redundant, and I would argue that it's not something that board staff should be doing. As soon as a set of data is identified, that's a process that's ripe for automation. So neither one of these two historical approaches is ideal, and for us, we kept things active. It'd be better if all this happened in one environment, shared experience where the requester and the provider can each do a little bit of the work. Next slide, please. So as we looked at configuring this solution, we made a couple of key decisions about those strategic choices. We wanted to shift as much of the work and the cost of understanding CTS data to data requesters. We wanted to shift that process of choosing specific data components to requesters. We wanted to automate the creation and delivery of data sets. And then we wanted to shift that work of harmonizing and analyzing data to the users. And it's part of that theme of giving the end user as much flexibility as she or he wants. It's our responsibility to make our data available and all the information needed to understand it. And then I think it's up to the community to analyze it. Next slide, please. So this is an overview of the infrastructure. What we wanted to do is have users come in, start at the public website, rely on some of the integrated components that we have, create a new secure web application, where once a project is approved, you researchers can get access to the web application's URL. You can use that app to configure the custom data you need, and then that app is going to automatically create and deposit data within our shared workspace where everyone can work on that together. And at this point, I believe, next slide, I will turn it over to Emma for a demo. Thank you, Vanessa.
Thanks, Jim. So I'll start back in March when we began to scope out a self-service solution. We decided to take a look at the entire universe of CTS projects. And what we found is that each analysis is a bit like a choose your own adventure story, where users choose their study design in that first column, which branches off into exposures, and then branches off again into the 3 possible endpoints, forming 27 possible combinations, which just so happens to be the number of possible endings to this choose your own adventure novel. The question then became, how do we build an application that can accommodate 27 combinations? Next, please. We do keep metrics on our projects. So we took a look and could see that 75% of our projects were using cancer data. And in fact, the vast majority of our projects are cohort analyses of questionnaire data with cancer as the endpoint, so the top row right there. And this became the basis for the app. We decided that the best way to accommodate for so many possible combinations was to start with the one that's most commonly requested. Next, please. This is the overall process we went through to develop our application. First, we identified and structured the data we wanted to make available. This process included identifying which variables we should make available. And as I already mentioned, we identified cancer as the starting point. Then we needed to do the work to translate our manual programs, the SAS programs that Jim mentioned, into automated queries. Previously, we would manually fill those in, and Jim and I worked closely to consolidate that program into a query that would support most CTS cancer analyses, and we provided this annotated code to a developer. The final step was to build the application. So we worked with a developer from San Diego Supercomputer Center and communicated all of our requirements. In the broadest sense, we articulated wanting users to go to a website, make choices, and then have their data automatically output into the remote desktop environment. But for the specifics, we needed to provide the data, the metadata, the queries, and exactly what the final data outputs should be. Next slide, please. We also sketched out design ideas. Myself and my coworker Jennifer used a tool called Figma to design prototypes for the app. What you're seeing here are 2 screens, top and bottom, that we made to show the developer what we had in mind. And the developer also provided some insight on best practices to make everything as user-friendly as possible. Next slide, please. I'll come back to these in some more detail after the demonstration, but just to give you a sense of what the app creates, these are the 5 custom deliverables generated by the app. There's a project-specific data set, which is read-only. There's a summary PDF of all the users' choices in the app, data calls in SAS and R, which both have starter code, and a data dictionary that matches the project data. Next, please. So now that you've seen what you get when you use the app, I'll walk you through the interface itself in a demo. If we could press next to start. This is the login screen where a user will type in their email address and then all projects associated with their email pop up. For this demo, I'll be using a lung cancer project as the example. So I'll click there to configure the project data. The first screen is select cancer endpoint. Define their cancer endpoint or type in the box as this will do here for lung and select it. A table appears with cancer site group, SEER code, ICD-03 site, histology, and totals in the CTS population. A user can then select all or go in and select and deselect specific histologies or rows. And at the very bottom, we see the totals. Back at the top, there's also this summary charts tab, and it will update to show the user selection. So we can see the total number of participants selected, as well as a chart of year at diagnosis by age at diagnosis. And then below, there are also distributions of histology and stage for the selected cancers. The next step is selecting start a follow-up. Here, users select the analysis start date, which is most often CTS baseline, but there are other dates available as well. Then a user chooses how they would like to treat prevalent cancer. So they could exclude all prevalent, exclude just prevalent of their chosen endpoint. So here, this would be lung, or to include everyone. The next step is selecting censoring rules. A user can choose the end date, either our administrative censoring date or any date that they choose before then. Then they're presented with a choice about censoring rules. And here we're going to go ahead and choose the default CTS censoring rules. What's really cool is that now you can return to the summary charts tab, and you'll see that all the numbers and charts have been updated. The chart there is now filtered by the time period that we selected, and our total number of participants up top has decreased a bit because we excluded prevalent lung cancers. Next, we go to select questionnaire data. We have over 1,200 questionnaire variables available here with a few different ways to look at them. Here you're looking by sections. So these sections, such as background and environment, are the section titles from the physical questionnaires that were given to participants. And you can expand these sections to see variable name, description, and then values when you hover over the description. The green variables that you're seeing there, the green rows, are pre-selected variables, meaning everyone gets those automatically. This is things like race and age. And then users can check the boxes to add additional variables, and they'll appear in the My Selections little box on the right there. Another option is to use the search. So since this is lung cancer, maybe someone would want to look up smoke, and they can see right away all the sections that have variables on that topic. We could also change the view to look by topic tags instead. So if we're interested in smoking and pregnancy, we could select this pregnancy filter here and see things like total years smoked before pregnancy and add those if they like. Then the last screen is a summary of all user selections. So we can see the endpoints, the dates, the questionnaire variables. And at this point, a user can click Generate Data, which triggers the output of the 5 deliverables that I mentioned earlier into the secure remote desktop. Next, please. So in a secure read-only output data folder, the project-specific data set and a formats file are output, and all of the other deliverables below are output into the user's project folder in the remote desktop. Next, please. Here is a closer look at the formats file. The app outputs a CSV as opposed to a SAS data set so that users can easily consume it in R or SAS. So we automated applying SAS formats for those who would like to use it that way, and this is just a prop contents with the formats and labels applied. Next, please. These 2 deliverables are the documentation. So the PDF summary contains all the choices a user has made in the app from that summary screen, but it also contains a study population table. This table automatically documents the final analytic denominator and why any participants were excluded. So for example, in this one, we can see that 213 participants were excluded for prevalent cancer. And the data dictionary matching the project data is also output. Next, please. Here is a closer look at the data calls in SAS and R. A user can choose whichever they prefer. They're both available to them. And these are just some frequencies that can be generated from it. There's a case indicator for, in this case, lung cancer, and a crosstab of lung cases and smoke exposure. Next, please. We are back to Choose Your Own Adventure, the magic of CTS data. And what I'd like to get across here is by using this Choose Your Own Adventure modular approach, we're able to accommodate other types of analyses and data, even though the ending that we focused on is the top path, cohort, questionnaire, cancer. Currently, our app supports fully automated data delivery for our most commonly requested analysis type, as represented by the solid green arrows. But because of this modular approach, any project using existing modules, like the questionnaire one that I just showed you, is also partially automated. These projects are the dashed green arrows. More sensitive data, such as biospecimen or geospatial data, can be joined post hoc to the output of the app. Essentially, we do not need to automate data delivery for all 27 possible combinations to enormously improve the custom dataset bottleneck. Next, please. In addition to this new app, we also have streamlined our researcher platform. And after registering, researchers can propose projects, review documentation, view status updates on their active projects. We'll be continuing to expand these resources, and it's through this platform that users can access the CTS web application that we've shown you today. Next, please. Data security is, of course, front of mind for everything that we've been building, and I won't go into the details of this slide, but the takeaway is that while our new application is accessible from the web, the data itself is all protected and stored in the secure San Diego supercomputer hosted environment. Next, please. What we've shown you today is our minimum viable product, which meets the highest priority data sharing need for the CTS, and it's flexible and scalable. As we use it, we'll continue to solicit feedback and improve it. One lesson that we've learned is that it's impossible to reduce the complexity or sensitivity of cancer epidemiology data. Instead, our controlled access application provides the needed security while also facilitating equal access and real-time collaboration. And lastly, every data sharing project, can we go back? Every data sharing project requires direct investments from both the data providers and requesters. There's no getting around this. And so our goal is to make the entire process as efficient and user-friendly as possible. Next, please. We have some quick acknowledgements. We'd like to thank the CTS Steering Committee as well as NCI for funding this work. Next, please. We'd also like to acknowledge the many people who contributed to the CTS infrastructure over the last 7 years shown here. Next, please. And finally, we'd like to give a special thanks to Jennifer Benbow and Kristen Savage at City of Hope, as well as Sandeep Chandra and our developer Kai Lin at San Diego Supercomputer. This group has put in so much work on this project, and just as in the photos, we've been smiling the whole time. Thank you.
Thank you, Jim and Emma, for a great presentation. We'll now open it for Q&A. As a reminder, you can type your questions into the chat and select all panelists, and we'll try to answer those during this Q&A session. So now I'll turn it over to Michael to begin the Q&A.
Thank you, James. Emma, that's really great. We've had a few questions now that have come through, and I believe that 2 or 3 of them are covering the same points. So I'll briefly summarize what they are and then ask you to address those. So one of the questions asks about how shareable the processes are for the infrastructure. Can the system be exported to other groups? Similarly, asking you to talk about the feasibility of making this whole app available to other epi studies so they can use it with their own data. And then can this be leveraged so we're not reinventing the wheel? I think those 3 questions are asking the same thing. I will hand that over to you to discuss.
Great question. The short answer is yes, with the caveat that every cohort is different, so that every cohort experience is going to be slightly different. But one of the reasons that we wanted to go through our decision making is kind of to emphasize that point of for a cohort to take what the CTS has done here and use it would really start with the cohort looking at, okay, what's their current process for sharing data, what do they want to make available, and then how. Once a team gets to that point, there are a couple components of this that could absolutely and pretty straightforwardly be used by another cohort, so we wouldn't have to reinvent the wheel. In essence, as Emma described, what we did was take things that had been in SAS codes and turn them into programming language that runs a query. So in that sense, the structure of the modules could be reused. The approach that we use on the slide to take CTS data, present it in a NoSQL database in a secure environment, that could certainly be replicated by another cohort. One of the things I believe Sandeep is on the chat. One of the things we've talked about is how, now that we've rolled it out, could we put together instructions, some open code for another cohort to come in and really build on what we've done, precisely so that another cohort wouldn't have to start from scratch. But I think in general, any cohort that has questionnaire data and wants to combine that with cancer outcomes and automate the process of selecting and delivering data could replicate what we've done here.
There are two additional questions. There's one question as to how you funded this endeavor. How was it funded? And then the other question is, who can request use of the CTS data? Should it be a PI or can a student also request the use? Thanks.
Emma, do you want to take the open request and I'll come back to the funding?
Yes. So anyone can request data. When it is students, we will work more closely with their faculty advisor and generally request a phone call and kind of keep up with them a bit more than we would with a PI, but anyone, generally our criteria is that they're with a research institution or academic institution, but otherwise CTS data is available for use.
On the funding side, I have to give a lot of credit to Sandeep and his team. And it was a shared cost between our infrastructure team and some of the resources that Sandeep made available through the Supercomputing Center. And one of the reasons that I did take that little bit of a divergence through that data sharing lifecycle and the cost questions is, for us, we looked at before summer 2019 how much time and energy and expense was being put forward to do those manual data set creations every single time. And so for us, it was a strategic decision that if we want to improve the efficiency long term, we were going to take this team of 6 and really see if we could make this self-service application work. And so we thought a lot about how much were we currently spending doing those manual steps, and could we make this investment to make that data sharing more efficient, more cost-effective long term.
Thank you. There's one rather specific question here asking about the requests. Are they saved and can you modify them later so you can adjust what you get out at a later date?
Emma, do you want to take that one?
Sorry, I'm not sure I caught the question.
So the question is that if someone put through a request and extracted data, will they be able to come back again and see the same queries and add to it, or are they starting again?
Yes, so they will be able to modify it and generate a new version, and they'll still be able to see the previous one. So we have versioning built in where they could go through the app as I demonstrated again. And because it's all associated with that project, if they were to click generate data again, just after making a few tweaks, it'll generate in the same place, but in a subfolder called version 2. And they could continue to do that. And it would output all the same things. So they would have a new PDF, a new data dictionary. So you can version things. And in the app itself, there is auto saving. So if they just wanted to add one more questionnaire variable, they could just open it and click the checkbox and generate data again.
Thank you. I think I have another question that follows on from the use of the app with other cohorts. How do you see projects which involve consortia coming together and would want to have harmonized data working with an app like this and other groups. I suppose in particular, if everyone was using your system, you may be getting out harmonized data to some extent. Whereas if there are other groups who are using a different approach, there's still going to be a post-harmonization step later. I wonder if you can talk a little bit around where you see this fitting in with the data harmonization.
Yeah, Emma, I'll take a first stab at this, and I'd love you to add to it. It's one of the reasons I mentioned that data sharing, data harmonization component. And one of the things that we've seen on particularly Cohort Consortium projects is there does seem to be kind of a least common denominator step at the end of that harmonization. At some point, all those data need to be combined in one environment. And many of those decisions are outside of any individual cohort. What we decided we could try to improve here is that process of getting the CTS data to a harmonized point and having that cohort consortium, that collaborative project team, give them as efficient, as quick, as user-friendly process of getting the CTS data to the point where then it can be extracted and analyzed wherever. We want to give some credit to the BitCap Consortium, Joe Kochel, and to OC3 and Britton Trabert. As we tested this over the last couple of months, they were graciously willing to give it sort of first use. And so what we did for those two projects was use this to generate the CTA data that we included in those consortium. They're now using the data within the secure workspace that we have, and ultimately this data will be extracted and they can analyze those with the other consortium data. So not all that process needs to happen here, but we want to make it as user-friendly and easy for those cohorts.
Good. Two additional questions. Can you use the app to request biospecimen, or you can only request dry data? The second question is, do you link the data to the Medicare files or to the National Death Index data files? If so, would use of external, with the use of remote desktop help in sharing data with researchers?
I think I could take a go at the first one there. For biospecimens, we do consider that slightly more sensitive or kind of high touch point data. So even though biospecimen data is not going to be automatically generated from the app, what we have done is created basically a form within the app where your request and what you want to do with the biospecimen data can be communicated with us through the app, and then we can have conversations and figure that out. But that way it's all still going through kind of one channel, and that you could even get started looking at questionnaire data or cancer data or whatever it is while we're still discussing the biospecimen aspect, which can be joined to that data.
And the second question is about linkage with Medicare files and National Death Index, and whether you can share the data using remote desktop.
Yeah, I'll take a stab at that one. And I do want to add one thing to what Emma just said. It relates to that earlier set of questions about can another cohort use this? A key component is the complexity of the kind of requests that we epidemiologists will make of a cohort. And as we looked at things like case control selection and control selection criteria, and the specific nuance of requesting biospecimens, that's an added level of sort of project-specific customization and complexity that right now we thought, let's sort of see how this gets used before we start to standardize this process. So it's really more of a process standardization than a technology or permission thing. For Medicare and NDI data, we are currently, as part of the next 5-year renewal of the CTS, we're linking with Medicare data. And so we'd like to, at some point, have those data included in here. And we are going to expand. Right now, we link with the state of California for death data. The results of those linkage are included in the application data that Emma showed you. And the more that we get updates to vital statistics data, updated cancer data, all of those will be included in the CTS data that are presented through this application. And as you said, Sam, for us, the right decision was then to have these data deposited in our controlled access remote desktop environment, because that facilitates versioning, as Emma mentioned, facilitates collaboration. It gives users the benefits of all of that shared workspace environment.
We have one question which I think relates to that now, asking about the data, of course, being not identifiable, but do you have concerns about re-identification of some of your data? The possibility of having perhaps rare events and then being able to re-identify it outside of your system?
I'll take a stab at that one, Emma. That's one of the reasons that we have the multiple levels of security in that controlled access environment. And I do want to clarify, earlier on I mentioned that some of the concerns about broader sharing were about having epidemiologic data in a quote unquote open NIH database. And that was a phrase that popped up in those public comments. My personal opinion is that all of these cohort data need to be in controlled access environments because of the very issue of identifiability, consent, and things like that. There are multiple steps, both in the creating of a user account for people who access our environment and the kinds of data that they can see within their remote desktop environment, that really minimize the chance of identifiability and re-identifying someone. We described some of those in the paper we published in CEBP last year, and I'd refer users to that. But I think we've taken as many steps as we possibly can to minimize, if not eliminate, the chance of that.
There's also a question about where the analysis is performed. Are all analysis performed within the CTS workspace, or do you actually give data to investigators to do their own analysis? And then is it possible for overseas researchers, international researchers, to have access to the data?
That one?
Yes. So most of CTS analyses are completely done in the remote desktop environment. The exception to this would be for people who are doing projects from multiple cohorts, and so they do need to do harmonization. We still encourage them to do as much of that as they can, like to get to the final variables before doing, we do a DUA and to do a file transfer so that they can harmonize that with everything else. But generally, we very strongly encourage that anything that can be done in the remote desktop be done there.
I have one specific question here asking if you will use the same approach for the other 26 journeys or just for the top searches.
Sorry, I don't think I caught that one.
So perhaps it is a question for you, Emma. Will you use the same approach for all the other 26 journeys that you've identified, or just top-level searches?
I think we'll see how this one goes. I think we have entertained the idea, as we've had some new proposals come in, of opportunities to have test cases and see kind of what we can do as we're working on those to make that process easier. For example, thinking about how we might do the same for hospitalization data, as Jim mentioned, how we might do the same for case control. But I think we would like to experience the benefits of this journey first and see how it goes and get feedback as we continue to muse on the other paths.
I have now what may be possibly more technical question, asking you to talk a little bit more about the underlying data structure where things are being stored, and how long did it take to get the data into this unified system?
So it's stored in a NoSQL presentation database, which is housed in the San Diego supercomputer secure environment. It probably took us, to get it into that system, it took us maybe 3-ish months. For the structure, of the data, we ended up going with something, I mean, this is kind of detailed, but since it was a technical question, going with a structure that was kind of both wide and long to allow for the query to account for people with multiple cancers, that there would be multiple rows for each cancer. But yeah, I would say it took some trial and error to figure out the best way to structure it for our existing data structure, but it was in the presentation database, I would say, around early summer 2020 after planning everything in March.
Thank you. I now have a sort of higher level question, which is asking to describe a bit about the administrative process involved, data sharing agreements, IRB approvals, how you track these.
Sorry, how we track?
Yeah, track the data sharing agreements, the IRB approvals, if they're needed, the sort of process involved in the first step of getting approval to use your data.
Yes. I don't know if, Jim, you would maybe be the right person to answer this one.
I'd be happy to. It highlights the issue that, you know, as soon as you automate one part, then it exposes kind of the next weakest link. And you're right, there's a lot of steps to get to this point. That goes to Emma and Jennifer and Kai and Sandeep for incorporating as many of those questions as possible in that kind of registration part. So as if someone were to come in and, you know, start a project with CTS right now, we would ask those questions as part of a new sort of integrated ecosystem. Behind the scenes, it's a combination of our website, our Salesforce system, but we do want to make sure that all of those boxes are ticked, so to speak, before we give access to individual level data to someone. And again, those are things that will really be, every cohort will need to configure them, but I think there are some universal processes, and we'd be happy to share details of kind of the nitty gritty of how we do that with anyone if they're interested.
There's a question about whether there's a cost associated with data request. And then the next question is the data connected to any genomic data that may be in dbGaP?
For the cost, there is no cost associated with requesting CTS data.
How about linkage with genomic data?
Is one of those things. Historically, it's been unclear whether CTS genomic data could be put into dbGaP, but we're revisiting that. As Emma showed you, right now, if someone wants to analyze CTS data with click data, we can use that partially automated process and make sure that anyone who needs those data can use them for their analyses.
Michael, do you have any questions?
Okay. I think we're probably coming down to the end of time now, so I think we should wrap up rather than hold people on for longer than necessary. I do know that I've got a list of questions here which I haven't been able to ask, so I think I can probably have to take this offline and follow up later. And if other people have other questions, I'm sure Jim and Emma may be able to answer those offline. So I'd like to thank everyone for their questions today. We've had quite a lot of them coming through. We'll ask Vanessa whether some of these are going to be recorded somewhere later. And to thank Jim and Emma for their time that they've spent putting this all together. It feels to me a little bit like they are test pilots for the future. I think this is where we all want to be or all want to go. And it's nice to see that they're showing us what's possible. And in time, I wonder whether we look back at this and think, well, we should have always been doing that anyway. And then also just like to thank Vanessa from UMBIN for organising the event and making it run smoothly. And maybe if I just hand over to Vanessa in case there are any technical details that you'd like to finish off with.
Yeah, for sure. Thank you. So thank you to our moderators, presenters, and audience for a great Q&A. Before we close today's meeting, we'd love to hear feedback on today's webinar. So a survey will appear as a pop-out when you leave today's meeting, so we look forward to hearing from you. And as we mentioned earlier, the presentation will be posted online in the near future. Please feel free to visit the website that you can find in the next slide for upcoming events. And if you want to continue the conversation, please feel free to connect via email if we didn't get to answer any of the questions in today's presentation. So with that, thank you again for your participation.
Thank you.
Thanks, everyone.